My topic in the first half of our presentation, sadly, for some of you perhaps, is not intellectual property. It's not Napster, it's not downloading, and it's not patents. What I'm going to talk about is making the web work for science. That is to say, I'm going to talk about the ways in which we could revolutionize the way that we treat scientific information, the way that the research cycle, the formation of a hypothesis, the generation of data, the production of articles, scientific articles, people doing research on, and particularly in the biomedical sciences, on research materials, actual things, plasmids, goop, mice, how all of that could be made faster, quicker, cheaper, how the transaction costs could be lowered, and how all of this could be done without any change to intellectual property policy of any kind, largely by using other means. But before I can do that, I have to convince you of something. I'm going to say that we need to learn from the World Wide Web. The World Wide Web was invented for science, not the internet, the packet-based network on which the World Wide Web runs. The World Wide Web was invented by Tim Berners-Lee in order to facilitate the exchange of scientific information, particularly the kinds of stuff produced by people at CERN, for example. And it was invented in 1992. That means in the United States it still couldn't drink legally. Yet it is almost impossible for us to imagine a world without the web. The fact that there was a world without the web seems strange, almost incredible, fabulous. And we are about as good at understanding how the World Wide Web works and why it works as fish are at understanding water. It is so pervasive, so implicated in everything that we do, that we fail to understand it. So I'd like to take you back to 1991, say, and imagine that you are constituted as a commission, as distinguished lawyers, business people, policy experts, scientists, citizens, to decide we're going to have this new worldwide computer system, and I just want you to help me to come up with a few design principles. So the first thing that we discover is that there's a real choice in how we might set up this worldwide computer system. One group of scientists presents the idea of a fundamentally closed system. There would be terminals on which one could do a limited number of things, print something, read something, maybe forward something if we're being democratic. But the terminals would only do what we allowed them to do. There would be 8 buttons and you could do those 8 things, and that would be the end of that. And the system would be controlled. Only people of whom we approved could get onto the system, right? So the Irish Times could get on, Science Gallery, I'm sure. Me, not so much. Because after all, I mean, who are you and how do we know that you're telling the truth? You would get the sports news, you would get the financial news, you would get the fashion that the system said you would get, and you would get it, and you would read it, and your interaction with it would be largely passive. And the great thing about this is it would be safe, it would be reliable, it would be authoritative. Then this other guy comes in, he's a little wild-eyed, he said, no, we should have a network that anyone can join, that is completely open, that is a dumb network, that will take any set of packet of bits and just translate it anywhere in the world, and we don't care what's in the bits. It could be kinds of stuff, kinds of communication, video, audio, interactive, we haven't even thought of, right? And at the ends, we won't have terminals, we'll have these things called general-purpose computers that can be programmed to do anything that you can think of how to program them to do. So wait, so this is a completely open system with open democratic standards that anyone can get access to, and anyone can do pretty much anything they want on it, and they can say anything they want, and they can send anything they want? So really, are you going to come down for system number 2? I mean, there'll be porn, check. There will be piracy, check. There will be the strangely articulate sons of Nigerian oil ministers writing helpfully to you to help them get out of a financial, check. There will be idiots, check, 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 check. There will be hate speech. There will be scams. I mean, honestly, how would anyone ever trust such a system? Would you trust information derived from a system like that? I don't even know who you are, where you're coming from. You know, the stuff hasn't been vouched for. I mean, no one would ever, for example, I don't know, rate a hotel on a site like that or rely on it or buy something. You imagine companies actually going to a system like that, as chaotic as that, and investing in it? You, I claim, would have voted down the World Wide Web with the same alacrity as you would have voted down Jimmy Wales' business plan for Wikipedia, which was, we'll have like a website and people can put stuff up and other people can edit it, and it'll make a worldwide encyclopedia in every significant language. It's like, yeah, right. Like, that's going to happen. We have a bias, a cognitive bias, that leads us to underestimate the benefits and overestimate the dangers of open systems. That doesn't mean open is always right. It's not. Lots of times we need control. We need authentication. We need privacy controls. We need intellectual property. But our point is we are systematically bad at figuring out how this would play out. Why is it that you can use the web for information when most of the information on the web is wrong? Right? Statistically, there are all these idiots out there, right? I mean, as someone said, we used to think that if you gave an infinite number of monkeys an infinite number of typewriters, they would produce the works of Shakespeare. Well, the internet is actually an infinite number of monkeys and an infinite number of typewriters, right? There's vast amounts of just nonsense out there, and yet you use Google successfully to navigate your life and to retrieve information. How could that be? Because it turns out that openness, when the platform is totally open, allows people to rate other sites by linking to them or not linking to them. And Google doesn't look at what the sites say, because the sites are wrong or lying. Google looks at who links to the sites. If the Science Gallery links to a site about science, it's probably a pretty good site. And Google rates those linkings. That's called peer review, except it's being done by all of us all the time in the process of just communicating. And by harvesting that data, Google gets a cognitive map of our world that uses openness to cure the evils of openness. Would you have thought of it? Well, I wish I had, because then I would be Sergey Brin and much richer than I am. But the point is, that's the kind of thing we don't think about. The World Wide Web, as I said at the beginning, was invented for science. Now, the World Wide Web works really well, they tell me, for porn. It's great for buying shoes. It's great for buying books. It's great for stalking your ex-high school sweetheart and then sneering dismissively at his or her current love interest's looks. It's great for tracking down obscure information, for looking at your genealogical data. It's great for figuring out whether the very nice hotel I'm staying in was liked by its patrons. What it's really not so good at is science. In fact, if you were to look at the way that the World Wide Web handles scientific literature, scientific data, you'd have to say, this looks like the web in about 1996. It really has none of the features that we would expect. Let me just give you a simple example of what I mean. If you're reading a book review of a book on a blog, you expect confidently that there will be a link from the book review to Amazon or whatever the local favored bookstore is, to their site, which will go directly to that book site. You are confident that when you go there, there will be lots of reviews by people, and you can look and see whether they like the book or not. You're confident that there will also be people who liked this also liked, and so that you'll get to see, like, yeah, people said it was a great book, but look at the other things they liked. They're really daft books. I don't think I'm going to buy this one. And you're confident that should you decide to unwisely buy that book, late at night after a couple of pints of Guinness, that when you click with the mouse, one click, because it's a patented one-click method, your credit card information is in there, and a secure electronic transaction is instantaneously formed, and the book is sent to you. No further information is needed. Utterly seamless. Now, imagine the equivalent in the world of science. Imagine that as you are running your high-throughput gene array to quiz some particular piece of genetic material to find out whether or not a gene expresses a particular protein, the throughput array is automatically, at that moment itself, querying all of the scientific literature to see if anybody else got the same result. So the scientists in the room are saying, wait, you're going to give me more information? I don't want more information. I'm drowning in information. There's far more than I can read anyway already. No. Don't want to give you more information. I want to give you better information. Right now, we are generating scientific information at digital speeds, but our method of processing is still analog. It's the Mark I eyeball. Sure, we've got search engines, but we haven't got anything like the sophistication of search that we have for many other things on the web. Why? Because much of the scientific literature lives behind paywalls. It lives behind the journals. That is to say, you can find that the word occurred, but you can't form an active link to the article because the article is there. The article could be searched by Google because Reed Elsevier or whomever has given them permission. But what you can't do, what Trinity College can't do, because I'm fairly sure it's signed contracts with hundreds of thousands of euros in liquidated damages, should it attempt to do so, is to go out there and text mine all of the digital journals to which it subscribes and see if patterns emerge, to see if they can say, look, here's this person writing about rheumatology and inflammation, and here's this cancer biologist writing about inflammation, and the same gene is involved in both, and I can see the connection, and the cancer biologist who doesn't read rheumatology journals is now going to be able to jump that gap. So imagine that as you run your high throughput array, you start seeing patterns like that pop up. Things that you would never have read because they're not in your discipline, because science, somewhat messily, doesn't confine itself to disciplines. It turns out that the same things can affect multiple disciplines, and it's hard for us to be educated in all of them. And imagine that also, of course, in this world, you would find that as you looked at the article would say, and I did this research using this particular cell line or this particular plasmid. Now, I should give you a little bit of background here. There are a lot of people who think that the kinds of barriers to scientific innovation that organizations like Science Commons work to end are barriers formed like, patents that are too broad. That's actually not true at all. What we're trying to do is lower the barriers, the transaction costs that no one wants, no one, anywhere, on any side. What's an example of that? When biomedical scientists do research, they are using frequently substances, plasmid, cell line, reagents, mice. In order to replicate the science and then extend it, you have to be able to get the stuff in all its goopy complexity, like in your hot little hand, before you can do it. It's not just digital. In an article in the Journal of the American Medical Association, when they tried to survey what caused most biomedical scientists to abandon a line of research that they thought was promising based on previously published research, what they said was, I couldn't get the materials to replicate the experiment. Remember buying the book? Remember how easy that was, right? Here's the reviews, here's the relevance, click, and the contract is formed. Imagine being able to look at the footnote of the article, and when you clicked on the plasmid that had been used, up pops a screen and says, this plasmid is available under a standard license to anyone who is a researcher in a nonprofit institution or educational institution. Are you such a person? Click. If so, enter your credit card number, and it will be on its way to you from Plasmids R Us. That, to a scientist, seems just ludicrous, because that's just not what happens. You have to go to your tech transfer officer in your university and say, I need to get a license. I'm not sure if this stuff can we send this out? And somebody else, one of your poor graduate students, has to go and generate it. And all of this takes time. It takes effort. Worst of all, frequently it takes lawyers. And so a large amount of it doesn't get done. What's the answer to all of this? Well, what should we learn from the success of the internet? First, I would argue, my first point, that we have this bias towards openness. I call it cultural agoraphobia, a fear of openness. We have this fear of the open system. Our experiences with property deal with stuff like this. This is not the kind of property that lives on networks. If I have this, you can't have it, and vice versa. If this, on the other hand, is the kind of property that lives on networks, if it's a file, if it's an image, if it's an idea, you can have it and I can have it too. Our instincts about how to handle it are derived from a world like this, where control is a very good thing. Someone has to own that field so we know who can plant it and who gets to reap from it. In the digital world, that may well be true, but we need to figure out exactly when it's true. So first, cultural agoraphobia. Second principle, make the system open. Make the fundamental system. In the case of the web, it was the protocols, it was the actual access to the network, and then it was the design of the stuff at the ends of the network, the computers that are general purpose computers. At each stage, we made the open choice, not the closed choice. In terms of the network, the closed choice is Minitel or CompuServe in 1994 or the early days of America Online, right? So that's here are the 17 things you can do, and here are the 8 sites you get your information from. That's not the web, right? In terms of the computer, we said no to terminals, yes to general purpose computers. In terms of networks, we said open. And then openness helped us solve the problems of openness, make the network open. Second, reduce the transaction costs. How does Wikipedia work? I mean, it's weird, right? An encyclopedia assembled by volunteers, which is compared relatively well in head-to-head tests with the Encyclopedia Britannica for scientific accuracy when Nature magazine ran an empirical study of the two. It's assembled by volunteers. They don't get paid. Like, how does that work? Well, it turns out there are lots of people who actually like to help, like to assemble things. And if you lower the transaction costs enough, a bunch of them are going to turn off Survivor and go and sit at their computers and assemble things. Lower the transaction costs, and people can share. There were always people who were willing to share. It's just with a worldwide network, you can bring enough of them together to build something, as Clay Shirky said, bigger than a birthday party. You can bring them together to build a worldwide encyclopedia. Lower the transaction costs. Open the network. Lower the transaction costs. Align the incentives right. Amazon had a really vested incentive in making sure that buying a book was easy and secure. And so, guess what? There it was. The people who review for Amazon, they get like #1 top reviewer and stars in their name, right? So they do Amazon's work for free. The people who work for Wikipedia get kudos within the Wikipedian community. It's not an enormous community, but within those community, you are a rock star editor, right? Believe me, it's actually true. You know, being a rock star doubtless would be preferable. But so align the incentives. How does this apply to the world of science? First of all, when the state funds basic scientific research, and both in the EU and the US, the state funds an enormous amount of core basic scientific research. The public sector finances an enormous amount of it. The private sector does an enormous amount of innovation too. Frequently that is later along the chain, that is taking the basic insights and converting them into commercial products, a system that works very well. I am talking here only about the publicly funded part. I want to be very clear about that. First, we take the radical step of saying, if we, the state, give you money to go and do scientific research for us, you have to make the results, the published results of that, available on the open web within X months of publication. That has been done in the EU. It has been done in the US. It only has been done in the last 3 years. Isn't that amazing? I mean, only in the last 3 years. Wait, we're paying for the research. We're giving you the money. And we don't bother to say, oh, and by the way, here's a condition that would make it available. So we make the research available out there. Open the system. Open the network. That's step number 1. But there's still other problems. What about the person who wanted the plasmid or wanted the mouse? We have to align the incentives. You're sitting there in your office. You have your doctoral students. You're going to tell one of them to go, and oh, we need a new mouse, and we've got to send it off. So that takes time. It gives one of your competitors a leg up in the scientific prestige market. So if you're, a sort of nervous, paranoid type, you might not want to do it. And you get no kudos for it in many circles. This is not true of every scientific discipline, I should hasten to add. But we don't build it into the reputation cycle. What would it mean to align the incentives? What about have an automatic tracking system? We have these materials. We license them under digital licenses so that they say, yes, you can get it under these conditions. And when the person provides it, you say, wow, Ian Brunswick has provided 7,000 plasmids to other people doing research. That's really impressive. He gets a +1 on the Framework 7 grants the next time he applies. He gets a +1 when he comes up for tenure review. That's aligning the incentives. I always try and pick non-controversial examples when I go and speak in other countries. So if you don't align incentives right, you could have, let's say, bankers making risky bets knowing they would then be bailed out, so their behavior would be effectively free to them but costly to you. That would be a bad thing. I try to stay, really away from the controversies. If you align social and private incentives, good things happen. In science, the scientists are smart people, nice people, and often sharing people. We have done a really poor job of incentivizing them to do the things that would benefit science. So take those insights of the web, apply them to science seriously. It has to be done by the funders. It has to be done by universities. And what do you get? What you get is better, faster, more efficient science at a lower cost. Every time we lower the cost of scientific research, good things happen. More scientific information, more accurate information gets to more researchers faster. And it does so in ways that problems can be solved. Right now there are diseases that we're not going to go and develop cures for because there aren't enough people who suffer them, or the people who suffer them are too poor. Now, lowering the cost of scientific research can't solve all of those problems. It can't, for example, solve the problems of developing anti-parasite medicines to deal with the diseases of the global poor. But it can sure lower the margin of cost that we have to pay. If we did for the web, if we did for science what we've learned for the web, I actually think we could revolutionize scientific discovery. In the areas where we have tried this, I think we've seen extraordinary development. Back in 1991, if I had said to you, yeah, I know you think this network's going to be a disaster, but like, amazing things will happen. Someone will be able to get a map of Dublin on Google Earth and layer Irish crime statistics on top of it. And somebody else will be able to take that, because it's open, and say, wow, that's really interesting. I have some statistical data about poverty, about child abuse, and I can layer that on the pattern of residents and see if something interesting pops up. And somebody else who's not as interested in those things can say, Dublin's traffic really sucks. I'm going to get the open traffic data. Unfortunately, in the EU, the traffic data frequently isn't open. In the US, it is. I'm going to get the open traffic data, and I'm going to build an app that's going to go onto your iPhone that's automatically going to say, here's the best route for you to go. And you expect that to be there, because you just expect that there's going to be open information that other people are going to be figuring out what to do with. One of the great insights I've learned about the world of the web is, if there are 1 billion connected people, at least one of them has a smarter idea about what to do with your information than you do. And that should be a happy thought, not a sad thought. The nice thing about what I've said here is it requires not a single change to patent or copyright law. So as I said, this is not a talk about intellectual property. That's not a talk about intellectual property. It's a talk about how to make the web work for science. What it does require us to do is to think about the virtues of open networks, to understand why we tend to undervalue their potential. Why did we rule out Wikipedia and yet Wikipedia exists? To understand how we can turn self-interest and lowered transaction costs into a way of revolutionizing what science has always wanted to do. If you were to ask Tim Berners-Lee how he invented the World Wide Web, he would say that the idea of a hypertext link is basically nothing but a glorified footnote. That's what footnotes do, right? Except the hypertext link was magic, because it actually didn't just tell you where the other book was, it took you there. And when that simple idea, based on openness, lower transaction costs, and the aligning incentives of other people who wanted to do things he had never imagined, was put out there, within 20 years, 19 years, it had completely changed our world. Wouldn't it be nice if we actually applied it to the domain for which he invented it, namely science? Thank you very much.
I don't know how you all feel, but my mind is kind of reeling after that presentation. It turned a lot of my expectations and the way I was thinking on its head. But I'm going to take some of those conservative and closed thoughts and get your answers to them. One of the things you talked about, Wikipedia, and obviously it's a self-correcting organism. In the case of science, and I put something out there and it's going to be open, peer review normally sorts that out. You're going to have anonymous peers all over the world reviewing. Sometimes there can arise a dangerous consensus which is wrong. How do you know when you put this out there and someone bases a particular line of inquiry on what turns out to be a consensus that was ill-founded?
That's a great question. That definitely happens. The 2 New Zealand researchers had a radical idea for more than 20 years that ulcers were not caused by excess stomach acid, but rather by a bacteria called H. pylori, and everybody said they were crackpots. They couldn't get their stuff published. And people said it's ridiculous, it's stupid. I mean, those crazy New Zealanders, etc. The only problem was they were right. So there is this difficulty. Thomas Kuhn, actually, in The Structure of Scientific Revolutions, wrote about it, saying sometimes the paradigms are so firmly entrenched that basically the solution, this is rather
a downer, is for the old scientists to die off en masse, the entire generation, which is not exactly, it sounds like kind of like the great leap forward kind of solution to things. That's not what I'm proposing. I think the answer is that our existing system and the system to come use a combination of methods, pre- and post-publication scrutiny. And I'm on the board of the Public Library of Science, which is a set of journals, all of which are available openly on the open web for you to do anything, including publish commercially if you want, and some of them leading scientific journals. One of our journals is called PLOS One, and it's an experiment because one of the great things about working with scientists is that you can persuade them that being humble about what we know about how things will work is actually the default hypothesis one should take. So with PLOS One, the articles come in and they are peer-reviewed to see that it is, in fact, science, as opposed to astrology, say. Did he use correct methods? Yes. Are the regressions correct? Yes. And that's it. They don't go to say, is this cutting edge? Is this the most interesting thing? Which is what traditional peer review does. Then the stuff's thrown up on the web. And then post-publication peer review kicks in. And what you find is some of this stuff is just junk, and basically nobody links to it, nobody's interested in it. And other stuff people really like because the turnaround time is 2 weeks as opposed to a year in many cases for a traditional article. If you wanted to ask me what my prediction is about the future of scientific publishing, is that we will have a mixture of these methods of authentication. Sometimes it's going to be the editors at Nature and Science, and they're very good, said this was important, and that's what put it out there. I would guess, and it's a guess, that we will see the benefits of post-publication peer review becoming more and more important. We already have that to some extent. Sometimes articles are published in lowly journals, and then people say, well, actually, this was much more important than we thought. But I think we will come to institutionalize it. We will come to build it into the system. It will actually look, and I mean this in a scientific way, not trivially, a lot more like the Amazon reviews and the if you liked this article, you liked that. We really haven't begun to use those ideas from social media, and I'm not suggesting that science be decided by how many people friend you on Facebook or follow you on Twitter. I'm talking about a scientific version of it. But we'll actually start using those insights to solve the problem you describe, which is fundamentally, this got established as the consensus view, but what if it's wrong? And that, I think, that mixture of methods with humility about which one is going to work is the solution that, again, the web teaches us.
One of the things you postulated was about the line of medical inquiry, for example, and you say that people who are researching in one area are probably not expert in all the relevant areas, but if you could cross-fertilize the information that's being garnered by each of them, maybe you'll get somewhere. The problem might be, though, for example, there is a consensus out there that Hep C, which is a very serious condition to have, is not transmissible between husband and wife, for example. I know, because I know someone, I know that it is. But if the consensus is out there that it's not, then a researcher in a particular line of inquiry may say, well, according to all the experts, it's not transmissible. Therefore, I will do these experiments with these human beings on a trial, and it could be potentially fatal. So it's that business of how, if I'm not expert and I'm having all this information thrown at me down the web, how do I know I can rely on it? Because I don't know enough to know.
No, that's absolutely right. I think what I'm talking about is not so much the stuff you're not expert in, the stuff that you are expert in, but it's in a domain that you wouldn't have looked to find it. So I'm talking about the person who's a cancer biologist. Cancer biologists think a lot about inflammation because cancer involves inflammation. People who are rheumatologists think a lot about inflammation because when your immune system attacks yourself, then you get inflammation. In each domain, there are clusters of things that they know, mind maps that they have painstakingly learned because their dissertation advisors beat them into them, ways of seeing the world. And those overlap because the basic principles of science make it the same, but they're subtly different. And the literature they read is different. So my point is, wouldn't it be wonderful if you could find the unexpected gem, the person who's working on your problem, but in a completely different domain? One of the things that I have really found to be wonderful about putting my book on the web for free is that it is found and used by people who I would never have imagined would find it of use. And they bring their problems to me and say, well, what about this and what about that? And I then learn about their domains. And in fact, in many ways, that's how this book was produced out of other stuff that I'd made available out there. So I think nothing can save us from the problem of error. That's just the condition of being human, right? Okay. Nothing can make error go away. What we can do, I think, is find the jewels in the material that we already know and cross-check them more rigorously against each other with more eyes. In the open source community, this is a really geeky slogan, there is a slogan, with enough eyeballs, all bugs are shallow, all software problems are shallow, easy to solve. And that people laugh at that, and I say, I don't see why you laugh at it. That's what Karl Popper said about the open society. You know, if you have enough eyeballs looking at things, and you know, someone is going to say, wait a minute, the emperor doesn't have any clothes on. And my goal is to increase the number of eyeballs that are working. And again, I want to stress that much of what I'm saying can be done entirely through things like funder mandates, things like, for example, the Wellcome Trust, which is a partner of Science Gallery. The Wellcome Trust does this with the people it funds. It says, you're going to publish it, we'll pay for you to put it out openly. Right? That's built into the grant. And we'll encourage you to do that. We'll encourage you to put the data set out there because they understand how this works. For the scientists are busy doing science, as they should be. They don't have time to create the entire architecture of the work they do, right? That's the job for policymakers. That's a job for scientists whose job is to fund all of science. And that, I think, is the solution to your problem.
I once met an American cop, and I don't know how the conversation came up, but it came around to the subject of sadomasochism. And I said to him...
That's a wonderful introduction to a story.
What do you think of sadomasochism? And he said, I don't mind as long as I can be the sado. Right? Now, you may wonder where I'm coming from.
Actually, I have absolutely no doubt.
What life experiences I bring to bear. But the point is about open information. It's great to think of every scientist as an altruist who wants to work for the betterment of humankind. However, there are those who are racing to a patent, those who are racing to a commercial fortune, those who think they're racing to a Nobel Prize. They'll be very happy to take your information, thank you very much, but I'm not giving you mine. Yeah. So that is a problem. I don't know. I feel that I give away something, and that guy gets the Nobel Prize, and I'm the person who made the breakthrough, not quite enough to get the prize, but he already had the other pieces of the jigsaw, and that maybe is part of the problem.
Well, first of all, by the way, the person rushing to get the patent, I'm very much in favor of that. I think, at least with our current system, patents drive a lot of pharmaceutical innovation, and there are problems with the way they run, there are problems with the patent system, but the basic idea of saying, this is going to be really expensive to develop, I'm going to need a monopoly over the end product, is something that doesn't bother me one whit. So there are certain times where not only do we not going to be open about something, but it's a good thing. Now, in fact, the patent is designed to encourage openness because the one requirement of patent is you actually put the innovation out there for everybody else to build on, even if to build on it they have to pay you a fee, as opposed to trade secret where you just keep it. So the patent system actually already embodies what I'm talking about. But your point is a different one. You're talking about the person who's an altruist and is made to feel like a sucker because the other person... And so how do you deal with that? Well, you can't ever get rid of that problem altogether. But I think you can do a couple of things to ameliorate it. One is the incentives point. If we align the scientific credentialing procedure and the scientific prizes and all the rewards that status can give in the sciences, which motivate a lot of scientists, and we can align some of the altruistic behavior so that the more altruistic you are, the better you do, then even the relatively self-interested scientist is going to be much more open about sharing. The problem right now is you share really with no incentive to do so, and the person can take. The situation I'm describing would actually make the problem you're describing better because the person who's sharing knows that it's more likely to get them tenure. If their data set is downloaded by 1,000 people, that's actually tracked. I can tell you, now I know there are no academics with egos in this room, but they exist. And some of them are obsessed with their citation counts. How many times was I cited? How many times was I cited? Now, I think they basically have a sort of embedded Google citation search running constantly with a little updated counter on their foreheads, like, this is how I'm doing. Wouldn't it be nice if that was tracking also how many times they shared? And that, I think, actually makes the problem, it doesn't make the problem you described go away, but surely it makes it better.
And a further point you made about the systems whereby publicly funded research is shared, and should be shared, and mechanisms put in place to make sure it is shared. Those of us who are currently watching our government struggle and trying to make a buck whatever way we can, and those of us who are bailing out the bank, and that includes everybody in this room who's a taxpayer, are thinking, why shouldn't the state, the taxpayer, someday make a buck for him or herself?
Yeah.
I mean, why shouldn't the state make a profit in the same way as a private company can make a profit from the money it puts into research?
So I actually think that's right, although we have to think of what do we mean by make a profit on? So I have no problem with the state getting reimbursements or recoupment in some cases where it's funded the initial innovation. But we have to, again, this is the humility point, be humble about what we know. So in Europe, by and large, much state-produced information, weather data, traffic data, satellite data, is owned by the government. And in many countries, it's actually forced to pay its own way. If you want to get the maps for the Ordnance Survey, you're paying off the Ordnance Survey. If you want to get the weather data to go back and model, you have to pay them off. In the US, the model is the opposite. All of that information is available at the cost of reproduction. And the cost of reproduction, as we know in the digital era, is not zero, but it is surely very close to zero. So Europe, we've done empirical studies on this. In Europe, you get about an 8-fold multiplier for every euro put into generation of public information of that kind. You get an 8-fold benefit back. That's a great return, right? Yeah. So that's, people plan better for their vacations, they do construction projects better. In the US, the rate of return is 32-fold. Why? Because all that information is out there, and AccuWeather and Weather.com and all those people then layer their own private stuff on top of it, make great businesses. Remember, I'm in favor of people making boatloads of money on this. I'm in favor of commercial exploitation. I just think it works better frequently on an open layer, a commons that we have set up. And then the great thing about stuff that's open is if it's free to get, then the person who wouldn't have paid for it but finds when it's free they can do something great with it, builds a business. The business employs people, it pays taxes, it produces better weather modeling, etc. If we go out and test this stuff empirically, often, but not always, I really want to be clear about this, we find that open actually is better in cold, hard cash. Not because we don't get commercialization, but because we get it later, and we get it on the basis of an open platform available to everyone, like the internet.
Okay, it's just such fascinating stuff. James is going to relax for a few minutes. We've got 2 more speakers, and then he will take, along with our other speakers, questions from the floor. But James, for the moment, thank you very much indeed.
Thanks so much.